Welcome to MEI Numerical Methods, Solution of Equations 1. In this video we'll be carrying on looking at the method of false position. Another interpretation of this method is as a weighted average, and we can see from the formula at the bottom here that it can be split up into two parts. So we've got a multiple of A and a multiple of B, and we know that f of B and minus f of A, which is a positive quantity, are in the same ratio as B minus C to C minus A. So suppose, for the sake of argument, that this was the ratio 3 to 2, then if we consider the interval from A to B, so this is in the ratio 3 to 2. So what this formula, the new version of the formula down here, is saying that we're taking a weighted average of A and B, and in the diagram here we've got C is closer to A, so we want a larger proportion of A than B. So in this particular case we would want we would want 3/5 of A and 2/5 of B. So the formula down here is just a general version of that. Another way of considering the method of false position is to look at the line from the point with coordinates A, f of A, to the point with coordinates B, f of B, and we've got the usual form of the equation of a line here, so that's y minus y1 over x minus x1. So both sides of the equation are expressions for the gradient. So you might like to pause the video and try this for yourself, plugging in the point C0, which we know lies on the line. So we can say that when x equals C, y equals 0. So plugging that into the equation, so first of all getting rid of the fractions, and then we want to make C the subject to the equation. and then two of the terms on the right hand side will cancel, and if we divide both sides by f of b minus f of a, we arrive at the formula up at the top here. So that concludes the video on the force position method, part 2, and in the next video we'll be looking at the Newton-Raphson method.